get to introduce Ali. This is Dr. Alison Wong, and she works at Sydney University in the business IT, like teaching computing to business people, which is very exciting. And we approached her because what she's doing with education and blended learning and online stuff, and what she sees with novice computing students at the tertiary level and students who didn't think that they would be programming today is really interesting. And so we asked her to come and talk to us about it. And so please welcome Dr. Ellie Wong.
Thanks. Hi, everyone. By the way, I did use ChatGPT to make the images for my slides if they look a bit weird. So I thought I'd start by telling you a little bit about me and give you some context around my teaching environment and also why I've chosen to talk to you guys a bit about educational literature today. So I did a Bachelor of Science majoring in physics and then minoring in IT. Then I went on to do a PhD in astronomy. During my studies, I did a lot of tutoring, and you guessed it, I tutored a lot of introductory Python. Nowadays, I'm a lecturer in the School of Business Analytics at Sydney Uni, and I'm still teaching introductory Python. When I first started teaching, I mainly taught using my gut instincts, and I was often drawing on my own experiences as a student, which is fine, but there are limitations to this. So firstly, when I was teaching for student me, and believe it or not all my students were like me. Secondly, it was hard for me to come up with new teaching strategies because I was drawing from my own experiences, and it was hard to think outside of that. Thirdly, I also found it challenging to talk about my teaching strategies to my colleagues because I would be telling them, I've done this, but I've done it based on a gut vibe, and that just kind of comes across a bit weird. So what changed for me was after my first semester of lecturing and after many years of tutoring, I took the Graduate Certificate of Education at the University of Sydney, which was a really great course, and it really challenged me to take a look at educational literature and apply that to my teaching. So when I was looking through the educational literature and now looking back at that, I've realized it's really helped me to grow as a teacher. In particular, it's helped me with these three things. The first one is I can justify my teaching practices both to myself and also to my colleagues. It's also helped inspire new teaching practices, and then it's given me a language with which to discuss teaching practices, both with my colleagues but also for applications for things like awards, grants, and one day in the future, hopefully promotion. So I really think that educational literature is a really powerful tool for teachers. Now, if you've ever read educational literature, or any literature for that matter, it's a little bit dull sometimes. And also there's so much of it out there, it's a bit hard to know where to start. On top of that, if any of you teach, you probably know that there's like 1,000,001 things that you had due last week that you still haven't done, and so there's no time to actually sit down and read literature. So I thought today I would share with you some of the things that I've learned from the literature that have really influenced my teaching practices and the way I think about teaching. I'm going to mainly talk about this in the context of teaching introductory Python programming, but it can be extended to other contexts. So I'll also note I'm not an expert in education, but I'm still hoping this will be useful, and I plan to give you my practical tips throughout the talk. So I picked my 3 favourite theories at the moment, and they are the worked example effect, constructivist theory of learning, and Bloom's taxonomy. First up, the worked example effect. This was first investigated by Swallow and Cooper in the 80s. They were studying high school students learning algebra, and they found that the students who were working and studying through worked solutions of algebra problems learnt better than the students just studying those same problems but just trying to solve them. Okay, I'm going to try and illustrate this to you now. We'll see how successful it is. Since you all know how to code, we're going to do this using crosswords. So here's an example of a crossword clue. So you have a clue. In this case, it's skiers oddly getting male teacher 3. So we're looking for a 3-letter word. And you can brute force it, but we're going to try not to do that today, okay, for this example. So without spoiling it, by a show of hands, who already knows what the answer is? A couple of people? Okay. So I'm not sure how much people here do crosswords, but when I first started, I was not very good. I'm still not very good. But when I would look at these, I would stare at them and just have no clue. I could read them backwards, I could try to read upside down and nothing. And that's kind of how I felt when I was a student, and the teacher comes to me and is like, write a program to do X. And I'm like, yes, no, don't know what to do. Okay, so I'm going to try and simulate that for you guys here. So if you already know how to do this, you're just going to have to imagine that you don't. Since I'm demonstrating the worked example effect, we need examples. Here are some examples. So this is the original puzzle, and you guys can go do it on your own time. I still have not solved it. So there are 3 clues we have here. They're kind of similar to the ones we have, and I'm even going to give you the answers. Okay, so having this now, who thinks they can now solve the clue? Okay. Couple of people, but not everyone. So this is meant to simulate when you were like learning and in class you got sample code, right? You got a problem and this is a solution. And I'd look at the solution and be like, okay, I get that code works, but I don't know how to get that. Or it's like when you're doing your math homework and you look at the back of the textbook and the answer is 42, and you're like, great, I don't know how I got to the 42. So these are examples. These are not worked examples. What we're going to do now is I'm going to get you to think, how long would it take you to solve the original clue with nothing? Secondly, how long it would take you to solve the clue if you had the clue and some examples? And then 3, I'm going to simulate giving you worked examples, so showing you how these clues work and how you get to the answer. Okay, and hopefully some of you or more people will be able to solve it by the end. So to keep things simple, all these clues follow the same pattern. There is an instruction and a description in each one. So we're going to start with 6 down. And it's traitor, dreamt, on and off. The instruction is on and off, okay? The description is traitor. So what we're left with is the word dreamt. On and off means we're going to go through the word on and off and take every second letter, and we're going to get a word that means traitor. And you'll see that we should get rat. You know, if you rat someone out, you're a traitor. So then the next one down, 20, walk upwards evenly. So the instruction this time is evenly, because if you think about even numbers, it's every second number, okay? Then we've got 2 words left. One of them we're going to take every second letter, and the other one's going to give us the description of the word we get at the end, okay? And we're looking for a 3-letter word. So this time the description is walk. We take every second letter of upwards, and we get pad, like to pad up and down a hallway. Okay, last one, 3 down. These are kind of fun. Creature ignoring odd bits of seaweed. So the instruction is ignoring odd bits of. The description, right, if we didn't actually know the answer, we're either going to take every second letter of creature and get something that means seaweed, or we're going to take every second letter of seaweed and get something that is a creature, okay? And you'll see that every second letter of seaweed gives us you, and that is a creature. Okay, so if you look at this back, I think the easiest thing is to pull out the instruction first. So we've had on and off, we've had evenly, and ignoring odd bits. Okay, so now let's go to the original problem we're going to solve. I'm going to give you not a lot of time because we don't have lots of time. But think about the instruction. Okay, then you're going to try and find a 3-letter word by taking every second letter of something to get something that matches the description. Okay, who here thinks they've got it? Wow, we did great. That's awesome. It doesn't work if no one gets it. Okay, yeah, so oddly is the instruction. You're taking every second letter. Getting male teacher is the description, and if you take every second letter of skiers, you get sir. There we go. So actually, when I first looked at the worked example effect, I found it kind of counterintuitive, because for a long time I really believed the best way you learn is by doing, not by watching other people do. Like if you're learning an instrument, playing a sport, or programming, you have to be the one doing it. But I'll say that for complete beginners, they really need these examples before they can get to the stage where they can do it. And I think we kind of forget that. So for students learning to write code, we really need to give them lots of examples of writing code. Coming out of the worked example effect, there were a number of things that I implemented in my classroom and I've adapted in my teaching, and I'm going to share them with you today so you can consider them. The first is to make time for worked examples. What this looks like for me is in class when I'm giving a lecture, I give an explanation, and then I have a question sheet and I pull out these questions and I work through the logic of solving each of these problems in front of the students, and I do a lot of these. Nowadays, I'm really deliberate about making time for that because I think that a few minutes of me solving a problem is way more useful than a few minutes of me trying to explain things over and over again, and they kind of fall asleep if you keep doing that too. The next one is to provide lots of worked examples, and that's not just examples, like just the questions, or examples where you have the questions and the answer. They need to have the working, because I don't know about you, sometimes I got questions and you just look, you take it home and you look at it and you spend 20 minutes looking at it and you've learned nothing. Sometimes you get the answer and you can sit there and do like an exhaustive search and try to figure out what the answer could be, but it takes a really long time and it's not actually that effective, and you don't know whether you've done the process correct or you fluked the answer, or if the process you've got is actually the most efficient process. You could be doing all sorts of crazy stuff that works, but it's not the best way to do something. So really give them worked solutions. Next one is to provide lots and lots of different examples. That way students can start to see patterns in the working, and so when they're faced with another problem, they can see how to rethink and how to kind of adjust their problem solving strategies. For me on the programming side with students, I create a lot of videos where I walk through how I'm going to generate code to solve a problem. There's a lot of commentary in there, so I talk about my approach, when I first look at the question, what I'm thinking, how I'm going to break it down into little pieces, how I'm going to test little sections of my code, and how I'm going to debug it. Now, a lot of the advice here puts a lot of pressure on you guys as teachers to do stuff, either in class or to develop resources. So the last one is something that you can kind of just let happen on its own, and that's to promote student collaboration. So for us, we're really lucky in our tutorial rooms. We have these big screens and we get students to work in groups and plug in, and as always happens, the strongest kid is like, I'm gonna do it, and they're the one that's sitting there typing. That's not necessarily a bad thing, because some of the weaker students are not feeling confident that they can do that, and they might not actually be at the level where they could do that, but it gives them an opportunity in class to watch their peers basically give a worked example before they're feeling confident to do it on their own. Now, I say that worked examples not only help students get to a place where they can code more quickly and independently, but it also helps students write better code. So related to student collaboration, we also have group work. And reflecting on my own experiences as a student, I did a group assignment once with a friend who was a way better coder than me. Every time I would write some code, he would delete it and write it better. And you know, I would look at that and go, wow, that's such a cool way to do it. I'm gonna save that for later. So what I realize now is that when we get students to write code, they're writing code out of the bits of knowledge that they know. It's one thing to write code that works and one thing to write good code. But if our students aren't exposed to writing good code, they never know how to do it, and it's hard for them to improve because when they're writing their solutions, they're not looking for things outside of their current knowledge. So I think by sharing more examples of writing good code can actually help our students improve. So in summary, what we want to do is we want to give students lots of worked examples, and that can help them get to the stage where they can write code and write code well. Okay, the next one is the constructivist theory of learning. So according to constructivism, learners construct their knowledge through their own experiences. So constructivism really advocates for things like discovery learning, where the idea is you take your student and send them out to the world and they just learn. There's lots of aspects of constructivism, but I'm going to focus on the theory of how we learn. So this is from Piaget in the 50s, and he says that basically our knowledge is made up of lots of little schema, and each schema kind of tells us how some bit of the world works. We gain new schema or new knowledge by two processes. The first is assimilation, and that's when we take new knowledge and just add it to our existing knowledge, and there's nothing that conflicts. So for example, and I think Jack might know the answer to this, or know this already, did you know that a group of wombats is called a wisdom of wombats? It's like a flock of birds, you have a wisdom of wombats. If you didn't know this, hopefully it doesn't conflict with your existing knowledge, and you're just taking that piece and adding it to your brain. Okay? That's learning through assimilation. Accommodation is when you're taking some information and it doesn't quite sit with what you already know. So for example, did you know that according to the botanical definition of a berry, a strawberry is not a berry, but a banana is? So Don't know about you guys. When I learnt this, I had to go back and think about what it means to be a berry before I was happy to kind of accept that. And so that's me revising schema that already exists in my brain, and that's learning through accommodation. Okay, so now we know how we learn. How can we take advantage of this in our teaching? First up, on assimilation, what we want to do is we want to relate new concepts to what the students already know. And most of you are probably doing this already because we know intuitively that that just works. So why does it work? Well, if you build knowledge for students on what they already know, they absorb the new information better, and you're reinforcing their existing knowledge. It's also easier for them to retain that information. The way I visualize this, if you give them a new piece of information and it doesn't relate to anything, it goes in and then it like falls out. But if you give it to them and relate it to stuff that's there, it like kind of gets grabbed and it sticks. It sticks for them. So here are some quick examples from programming that you probably or maybe already use. The first one is when you're teaching if and else statements. You know the example, if it's raining, take an umbrella, else take a hat, or something along these lines. This one is when you're relating logical code decisions to everyday decision making. So it makes kind of intuitive sense for the students. The second one is how I like to teach and or, and telling students that for and, you need 2 truths to be true, and for all, you just need one of them. I tell them, if you go to the shops and you ask for fish and chips, then you kind of are expecting both, and if you don't have both, you're not satisfied. But if you go to the shops and you ask for fish or chips like a crazy person, then you only need one of them to be satisfied, but you're also happy if you get both. Okay, so moving now into accommodation. The advice is to encourage cognitive dissonance. So that's where you try to get the students to be wrong, and that seems a bit weird, but they're going to learn from it. So you're helping them learn from their mistakes. What I do is, based on talking to students in the classroom or seeing how they're doing on assessments, I go through and find examples of common mistakes and misunderstandings, and then I go through and make examples where I expect them to get it wrong, not because I'm trying to trick them, but because I want them to learn. Here are 2 programming examples. So the first one is 5 times 2 gives you 55. Yeah, so you probably know this one. It's looking at variable types, and here's like an example of code that might demonstrate this. What I often do is I get students to make a prediction, so get them to either make it in their head, talk to the person next to them, or if they're feeling brave, they can say it out loud. And that just makes it a little bit more fun and interactive. The next one, I'm going to be super impressed if anyone knows what this is meant to be. Yeah, this one is scope. So the cage is meant to be the function, and inside the function X is doubled, so inside the cage there's 2 rabbits, and outside there's just 1. But yeah, so what I tend to find with some of these examples is students often remember them because they remember getting things wrong. And so what I do is I try to work really hard to create a safe space for the students, for them to be wrong, and know it's okay to be wrong, because learning that you're wrong is still learning. And I also remind them that it's better to be wrong in class than in the test. And that seems to work. Okay, the last one I want to cover is Bloom's taxonomy. So this is a way to categorize educational goals. It was first presented by Bloom in the 50s, and then it was revised in 2001. We're going to be looking at the revised version. So if you're wondering why this one looks like a cake and this one looks like a pyramid, I couldn't get ChatGPT to make a cake without it just looking like cake. But Bloom's taxonomy is represented sometimes with the pyramid or the cake structure, but the idea is as you're moving up the levels, students are showing an increase in their understanding. So Bloom's taxonomy is very general. There have been efforts to actually make one specific for like computer science, but they haven't really taken off. So I'm going to stick with Bloom's, which is also probably one of the most famous ones. What's great about Bloom's is it's really simple, but when it's really simple, sometimes it doesn't capture all the complexities, so you often have to adapt this for your teaching, and it means each of these levels can mean different things depending on context, right? This will look different for someone learning to program and someone writing an essay. The point I want to make today is that I think in programming, we tend to focus on the top level, which is create, like write a program or build a website, and then we forget about the lower levels. And it might be tricky to know like what you can put in these lower levels. So I wanted to give you guys some examples of those types of questions, and hopefully that can help you guide students to the top of the pyramid. So the first level, the bottom level, is remember, so recognize and recalling facts. And one example of what you could do for students is get them to just make sure they're remembering keywords and also syntax. You can do this with something simple like a multiple choice question. I often get these students to do it in class and then get them to vote on what they think. And it doesn't really take much time. You can also set it for homework, but I think it really pays off in the long run because these are short, quick activities, but can build understanding or catch misconceptions really early. The next level up is understanding. So understanding what the facts mean. So for programming, this can look like you just want the students to be commenting code or explaining code snippets. They can either do that individually, or you can just get them to talk to the person next to them and explain what code does. This question here, they've got some code and they need to explain why the output of this code is 12. Okay, the third level is applying. So applying the facts, rules, concepts, and ideas. The example I have here is you're teaching students, how to use mathematical operators in Python, and they're going to apply that by performing some sort of calculation, which later might be part of a bigger program. Okay, it's getting tricky now. So analyze is breaking down information into components or parts. So for example, you can give students some code and they have to draw like a flowchart for it. Or you can get them to trace values of a variable through some code. The question we have here is, here's some code, what is the output? This forces students to go through line by line, keep track of the values of variables, evaluate expressions, and also determine which of these lines of code are going to execute. Okay, we're still not even at the top. The next one up is evaluate. So judge the information or ideas. So examples I have are debug or test some code. In this question here, they've got some code, it does not work. On the right, they have what the code is meant to do, and the students have to go and evaluate, like, does this code work? Why doesn't it work? Where does it break? And what do I have to do to fix it? Okay, so you can see there's a lot of levels before we actually get to the create level. The last one is the create bit, which is combining parts to make a whole program, and for introductory program, I think that's the whole write a program to do X, and we have tons of these most of the time. Here is my quick summary. This is not an exhaustive list of what you can do, but, so it's not an exhaustive list, but it will also change depending on what you're teaching. So again, this is for introductory programming, but if you're teaching students to build a website, what you'd probably do is the create level becomes build a website, and then you kind of have to backfill all of the lower layers. So the main takeaway I want you to get from this section is to focus less on the create part. What I've noticed with my students is I ask them to write a program to do X, and if they don't get it, I sit down with them and I try and explain everything, and then what do? I send them back off to write a program to do X, and usually that's actually not that useful. What I want to do is try and build more of these kind of lower level exercises into their learning and help them get to the stage where they can write the program to do X. I'm really guilty of not doing this, and sometimes I'm wondering, why are they struggling so much with writing their program? And I realize, maybe I haven't really taught them how to debug code, and that's kind of important. So yeah, that's on me. The next one I have is to try and incorporate some of these other lower levels into your assessments. With programming in particular, we do go straight to create because there's a lot of project-based things. And sometimes the students aren't really at the level where they can create yet. It doesn't mean that they don't know anything, but they're having trouble showing you what they know because you're not giving them an opportunity to demonstrate their understanding at the lower levels. The last one I have here is that you can, if you've got a suite of all of these different kind of levels of questions to give students, you can use it to understand where they are in the learning. I think we often assume that students are getting it until they just don't. And we don't know where they're going wrong or why they're not getting it. If you kind of build with these questions, you can see exactly what skill they're missing. And it helps you diagnose what you should do, what the problem is, and how you can help them better. So that covers the theories I wanted to share with you today. What I wanted to leave you with is a way to access all of the gold that comes from educational literature without having to read the papers yourself. So the first resource I'll point you to is the Universal Design for Learning, which is the UDL guidelines. It's just a website, and basically people out there have gone and read a lot of these papers. They've taken all the important bits and they've summarized it in this table, and you can kind of treat it as a checklist of things that you might want to think about as you're teaching. It's overwhelming to do all of them, so maybe just pick one or two and kind of work to incorporate in more. What's really nice is if you click on them, I know it's really tiny text, but if you click on one of them, for example, this is offer action-oriented feedback, it'll go into more detail about that dot point. So it'll tell you some practical advice for bringing this into your classroom, and also it'll tell you why this is important for your students. Now, if you're still super keen, there is a button for research, and if you click that, it'll give you a huge list of papers. Now, notice here we have A to B for just one dot point, so it's a lot of papers. I wouldn't necessarily recommend reading all of them. What you might want to do is skim through the titles, pick ones that look interesting to you. Then you take that paper and just read the abstract and the conclusion. They're nice and short, and they will tell you the main takeaways from that paper. If you're still finding it interesting, you can read the introduction, which will give you a nice summary and overview of that particular topic, and it will also link you to other papers. And then if you're interested, you can read the whole paper. Now, for those of you who don't have time to read, another way to get into this is to listen to podcasts. So here's a couple of examples of some of the popular ones. What they do in these podcasts is they often get these guest speakers in to talk about different teaching strategies. It's really cool because they have people from a range of different backgrounds teaching at different levels. They talk about different topics, and they're pretty up to date because they're pumping out episodes pretty regularly. The best bit is they're easy to understand because it's human people talking, as opposed to reading really technical papers. Okay, so that's it from me. I hope there's been something here you can take away and use in your classroom, or that it has inspired you to go and look at some of the literature yourself. Thanks.
Thank you. That's not another step. I know what I'm doing. That was amazing. Thank you so much. Enjoy
Thank you. Oh, there's a sticker.
Yeah. I don't think we've got time for questions right now, but I have a microphone, so I'm going to ask you a question. Can you go back to the URL for this resource? Because I want to give people an opportunity to go there. Mostly, I didn't take a photo of that slide, but I don't have someone take a photo of that slide for me. Thank you. Excellent. But if you have questions, I'm sure you can come and talk to Ali in the break.
Yep.
Wonderful. We've got 10 minutes now, and then we're going to have another talk. Stay tuned.
Thanks.